Earlier, you learned how to interpret what your flight instruments were telling you. Now let's take a look at the details of how the gyros work to give you information. You're probably familiar enough with the attitude indicator to know that it's not a measure of a pilot personality trait. Just like a spinning top, the attitude indicator uses the gyroscopic property of rigidity in space. The white horizon bar that separates the blue sky from the brown earth is attached to the gyro inside the case. While it wasn't emphasized when the attitude indicator was introduced, you probably realize by now that the horizon bar remains parallel to the natural horizon no matter how you maneuver your Skyhawk. It's attached to the gyro and it's rigid in space. The marks parallel to the horizon bar above and below are there to give you reference so you can identify desired pitch attitudes. The white lines converging to a point on the brown earth help give the illusion of depth and distance, but they also serve as secondary references to help you identify a desired bank angle. Use of the attitude indicator is instinctive if you remember that the horizon is immovable. It's like being behind your Skyhawk in space watching it fly. And you can fly the little airplane with the real airplane's controls, just like a video game. By the way, if you see an old-style attitude indicator like this with no blue sky or brown earth, reorient the picture in your mind so that the horizon bar is horizontal. Then you can easily determine what the little airplane is doing. In this case, the right wing is down and the nose is on the horizon. After all, there's a reason that horizon and horizontal sound alike. One last thing, precession causes an error when rolling out of a turn in which you've changed direction about 180 degrees. When you level the Skyhawk's wings with the natural horizon, the little airplane may show a very slight bank in the opposite direction. It's no cause for alarm, and a built-in correction mechanism will fix the problem within a few seconds. The heading indicator also operates on the principle of rigidity in space. The dial represents horizontal directions, but through a gearing arrangement, it has been mounted vertically so that you can see it more easily. Looking at the dial, you can think of it as letting you look down on your Skyhawk from outer space. Then you can tell yourself the little airplane moves. If you think of the little airplane etched on the instrument glass in this way, you'll always know which way to turn to an assigned heading. Now, you already know about the resetting knob down on the lower left side. You should reset the heading indicator to the magnetic compass about every 15 minutes. This is because unwanted precession causes the gyro to drift from the correct heading. Remember, when you read the magnetic compass, you'll want to be at a constant airspeed and with your wings level. That's so you're not introducing dip error. It's a good idea to cross-check the attitude indicator and the turn coordinator to be sure you're not turning. Matching the heading indicator with the magnetic compass is harder on north-south headings because the magnetic compass tends to be squirrely on those headings, but it's still doable. While you're at it, don't forget the deviation from the correction card on the magnetic compass. Now it's time to look at the gyro that operates on a different principle and power source. The electrically powered turn coordinator operates under the principle of precession. With the little airplane's wingtip on the index, it takes 2 minutes or 120 seconds to make a complete circle. Since a complete circle is 360 degrees, old-fashioned arithmetic tells you this is 3 degrees of turn per second. It's called a standard rate turn. That's fast enough to get the job done, but it doesn't require excessively steep bank angles. It's important for you to realize that the turn coordinator does not measure bank directly. But if the balance ball here in the inclinometer is in its cage, and if the heading indicator says that you're turning, then the airplane must be in a bank. So it's okay to think of the turn coordinator as an indirect indicator of your bank if you're making a ball in the middle turn. By the way, you might be interested to know that the bank angle required to produce a particular rate of turn increases with airspeed. For instance, at 85 knots with the turn coordinator's wingtip on the index, the attitude indicator will show slightly more than a 10-degree angle of bank. On the other hand, at 110 knots, again with the turn coordinator's wingtip on the standard rate index, the attitude indicator will show slightly more than a 15-degree angle of bank. Just think about how much the track is banked at the Indianapolis Motor Speedway. The faster you drive around a curve, the steeper the road needs to be banked to keep you from being slung to the outside of the turn. So now you know how different gyro instruments use different gyroscopic properties to do their jobs and help you do yours as well.